Hi Aditya.
Hi Kavya.
I think we last met in that linear algebra through geometry course.
Yes.
How is it?
Yeah, it was great. I learned a lot of things from that course. Now, actually, I'm looking for something similar in machine learning as well. I want to understand the mathematical foundations in machine learning.
I see. I wonder if Prof. Arulalan, the one who taught the other course, if he's taking something in these lines.
I wish there was a course similar to that.
Yeah. Hey, isn't that Prof. Arulalan?
Yeah, that is. We should go and talk to him.
So Gaurav, I think you can go ahead with this.
Okay.
Except this plane must be a bit visible.
sir.
Okay.
Cool, sir.
Yeah.
Hello, Professor. I'm Aditya, and this is Kavya from your previous course.
Oh, hello guys. Nice to meet you. How was the course?
The course was great. We really understood a lot of things. We're looking for similar course in machine learning as well.
Uh huh.
Oh, wow. That's very interesting. There's a course that Professor Arolan sir and Dr. Ashok Rao are actually offering. It's a 12-week course on the mathematical foundations of machine learning, and it will start in July.
What are the course contents?
So Aditya, this course, whatever we are planning to do for July, is titled Mathematical Foundations for Machine Learning, and we plan to cover the three pillars of this machine learning, the mathematics of machine learning, basically linear algebra, probability, and multivariate calculus and optimization. So that will be the contents for the course. We plan to do linear algebra for 4 weeks, probability for 4 weeks, and optimizations and applications for 4 weeks. So that will be the contents.
Sir, what about the linear algebra in the previous course? Like, how is it different from now? Like, how would this be different from the previous course?
Well, that previous course, whatever that we had done, it was an extensive course on linear algebra alone. But the idea was there to convey concepts through visualizations and stuff. And that's a 30 lecture course basically. Here what we have done is we have brought in an abridged version of the linear algebra ideas, which is similar to what we had seen there in that course. But one of the most significant difference that we are going to see here is we are not going to talk linear algebra, the language of linear algebra as such, because most of the times what happens is when you do machine learning and you do linear algebra, there's no connect between these two guys. So we will be covering the idea of linear algebra in the language of machine learning. So what you would have actually seen as vector space could actually become the feature space here, right? What you would have seen as linearly independent vectors would actually become, independent features here. So we are actually going to talk the language of machine learning as applied in linear algebra. So that will be the course content for the linear algebra part of it.
So, sir, what would be covered in the optimization part?
Well, that's another key aspect of your machine learning. Optimization, from students' perspective, it is always like minimum effort, maximum reward. That's what you look at. So optimization is something like that. See, when you do prediction, when you do classification and things, you naturally will have error because you don't have entire data to work. So what we are going to tell you is like, how do you, choose your model parameters such that this error or the classification error or probably the prediction error is minimized. So the optimization algorithms would actually involve that. We'll be covering multivariate calculus. We'll also be covering matrix derivatives, which is something new, which is typically not done. And we are also going to look at gradient descent algorithms, and we're going to look at Lagrangian based optimization. So you have like constrained optimization techniques and unconstrained optimization techniques. So we'll be covering all that as a part of this course.
Sir, what about probability? What all are covered in it?
Kavya, in probability, we are going to start from very basics, talking about sample space, events, and all those things. And then we go to random variables, multivariate distributions, and conditional probability. We're going to do a pretty significant portions of probability in this course. See, again, the focus is on interpreting things. For example, when you say disjoint events, you say there are two events A and B which are disjoint. What we understand from that is if A occurs, B does not occur. That means I am able to completely update about event B upon the occurrence of event A, which means I get some information I get to learn about the other event based on occurrence of one event. So these are things which are very essential, especially in machine learning, because you say that I have these features. Does this belong? What is the probability that it belongs to this class? Right? You get into conditional probability and so those things are basically done here, right? So typically we are covering again probability for 4 weeks. We are also doing some inequalities and we go till central limit theorem. So that will be the contents for probability.
Sir, would this be the scope for this course, or would there be more topics?
We are also looking forward to include the ideas of support vector machines, neural networks, perceptrons, logistic and linear regressions, and so on. So I think we will include all these things in the course, and that's how the course is going to proceed. This will be dealt by Dr. Ashok Rao. This part of it would be dealt by Dr. Ashok Rao.
Sir, will we have visualization like the previous course as well?
Well, that's Gaurav's forte. I think he will answer the question.
So you guys have been through the previous course, right? Where we showed animations that elucidate concepts and show it in such light that you can retain these ideas. So similarly, we are going to do this across all the topics that sir mentioned just now. Linear algebra, probability theory, as well as convex optimization. So for instance, we are going to show gradient descent, and that is going to be in an animated form so that you can retain those concepts. So we are working on all these ideas so far.
So typically visualization helps you understand the ideas better. So yeah, I think he has answered your question.
Yeah, that's great. Sir, when would the course start, and can we register for the course?
I think the course is scheduled for July. Registration, I'm not sure like when it is going to start. You can keep a tab on the NPTEL website, and once the registration starts, you could probably think of taking that course. I hope I'll be seeing you in the course.
Yes, sir, sure.
We're looking forward to it.
Thank you, and all the best, guys. Thank you.
Thank you, sir.
Thanks a lot. Yeah, bye.